In this video, we will understand the concept of Lepton number and Baryon number, which are the two most important quantum numbers of particle physics. For their understanding, we will start with the matter content of standard model, which consists of two classes of particles. One are known as the leptons and the other one as the quarks. We have 6 leptons and 6 quarks in the standard model. Out of 6 leptons, we have 3 electrically charged leptons, which are electron, muon, and tau. These 3 leptons have an electric charge of -1, while we have 3 electrically neutral leptons, which are electron neutrino, muon neutrino, and tau neutrino. These corresponding neutrinos to these electrically charged leptons are electrically neutral. Similarly, we have 6 quarks in the standard model, which are the up quark, charm quark, and top quark, while we have 3 other corresponding quarks, which are down, strange, and bottom. So these are the 6 leptons and 6 quarks. Now we will define lepton number as we assign each lepton a lepton number of +1. For example, we have electron, which is a lepton, so its lepton number is +1. Similarly, for example, we have tau neutrino, which is again a lepton, so its lepton number is 1. So each lepton is assigned with a lepton number of +1. Similarly, if we have an anti-lepton, for example, we have a positron, which is an anti-lepton, so its lepton number will be -1. Similarly, if we have an anti-muon neutrino, which is the antiparticle of muon neutrino, then its lepton number will be -1. So for each lepton, we have a lepton number of +1, and for each anti-lepton, we have a lepton number of -1. Now moving toward the quarks, we assign each quark a baryon number of +1/3. And as quark contain colored charge, so they can form bound states, and we have 2 possible bound states. One is known as the baryon state and the other one is known as the meson bound state. Baryon state consists of 3 quarks or 3 anti-quarks. These 2 possible combinations are known as baryons, while if we have a combination of quark and an anti-quark, then this bound state is known as meson. We have only 2 possible states of quarks due to the condition of quantization of electric charge. As baryon consists of 3 quarks, so its baryon number will be 3 multiplied by 1/3, which is equal to 1. So for each baryon, we have a baryon number of +1. And for each anti-quark, we assign a baryon number of -1/3. So if we have an anti-baryon which consists of 3 anti-quark, so its baryon number will be 3 into -1/3, which is equal to -1. Hence, for each baryon, we have a baryon number of +1, and for each anti-baryon, we have a baryon number of -1. As meson consists of a quark and an anti-quark, so the baryon number of meson will be 1/3 -1/3, which is equal to 0. So for meson, we have a baryon number of 0, while for baryon, we have a baryon number of +1, and for anti-baryon, we have a baryon number of -1. Now we will discuss an example. For example, proton and neutrons are the 2 examples of baryons. So the baryon number of proton and neutron will be +1, while the baryon number of antiproton and antineutron will be -1. So this is the concept of lepton number and baryon number. I hope this video gives you some conceptual clarification about this concept. Kindly subscribe this channel for more physics videos.